Now let's look at the functions. C was divided, whether this one was within big O. So C is a pretty tricky one. The other one that was a little bit more divided was E. If you weren't sure about the others, definitely try with the definition. You should be able to prove by picking values of C and N0. So what about this one? This one gets both at understanding the definition and being a little bit comfortable manipulating logs. For this to be the case, this is f of n or f of s, this is g of s, right? So the question is, are there constants where is less than is always less than that for all s greater than n0? If we can pick the constants that make this inequality always true, that would show that it is in big O. If we can show that whatever the constant is, we can always find some value of s that violates the inequality, that would show it's not. What is log of s squared? Can we simplify that? Good, yeah, so that is 2 log s. Definitely your intuition that when things are squared, that might change the asymptotic class, whether it's in big O, is a good intuition. Once things are inside logs, that's a bad intuition. Within a log, the inverse of exponential. So doing a square within a log is not a big deal. For all practical purposes, and I think the quote at the beginning of the chapter, or maybe the beginning of the other chapter, log is basically a constant. Logs are small constants. They matter because if the input's big enough, the log does increase. So it's not really a constant. In this case, now we have that. This is the equivalent of 1/2 s2 log s. We can simplify that. So what value do we need to choose for C? Well, we can choose almost any value for C. This is going to work. 1 is a good choice. It would be obfuscating to pick a bigger value because it actually works for C equals 1 and it works for N0 equals 1. So that is in big O. So what about this one? So this we should be able to answer very easily from the definition. For this to be in, we just have to find C and N0, right, our definition. So what do you want to pick for C and N0? It's inequality, so we don't have to do a lot of math to figure it out. Let's pick N0 as 5,000 and C as 1. Or we could pick N0 as 3102, C as 1. So the one that wasn't was the squared. Do you want me to do that, how we would show that s squared is not in big O s log s? That I think people have the right intuition. Actually proving it to back up that intuition, I think, is more difficult. So the question was, is s squared in big O s log s? And in this case, it is not. To satisfy the definition, it would have to be the case that, so we have s squared is less than or equal to c s log s. What value can I pick of n that would violate that inequality? So it can't be a constant, right? So any constant I pick, you can pick a c value that's going to make this inequality true. So the value I pick has to be a function of C and N0 in some way. Right? But this is the way within the for all and there exists, I get to pick last. Right? You pick C and N0, whatever you pick. If I can pick an N that makes the inequality false, then I've shown that it's not within the big O. So it's probably some function of C. The N0 just means, well, it has to be higher than N0. But usually getting higher than N0 is easier. What function of C should it be? First one we'd try, what if we just pick C? Would that work? Sorry, this is S. I switch from S to N, this should be S. So that would mean C squared is less than or equal to C times C log C. Is that okay? That looks true. Is that satisfying what we need? We want the inequality to be false. Showing it's true definitely does not show that it's not in big O. Showing it's true for some value doesn't show that it is in big O. To be in big O, it's got to be true for all values. So that didn't work. What else could we pick? Yeah. Okay, we could pick C squared. Good. And you may think, oh, is that allowed? C is a constant. We can pick any function on C we want, right? We could pick 2 to the C. We could pick C to the C to the C. We can pick anything we want because it's a constant. So if you pick C squared and plug it in, now we're going to get C to the 4th is less than or equal to C times C squared log C. Our goal is for this to not be true. So is it true that that's not true? Yes. And the reason it's true, well, this is c cubed, and this is less than c. Yeah, we've got to also pick greater than n0, but that's easy. If this isn't greater than n0, we can just increase it until n0. Yeah, question? Oh, you're right. Sorry. For this one, that's s. This is less than c. That is 2 log of c, which for some really small c values is not less than c, but for any interestingly big c value is definitely less than c. Good.